In the last part of chapter 6, we're going to do what we did yesterday with the linear inequalities, but this time we're just going to put two of them on the same graph, and it's going to be a system of the linear inequalities. So by the end of this lesson, you should be able to solve systems of linear inequalities by graphing, and then write and use them to model real situations. So we'll have some more story problems. So think back to what we did yesterday, where we either made solid or dashed lines and then we shaded either above or below the line. Today we're going to do that, except we are going to have two or more together. Remember, in this class we just do two. When you get to algebra 2, you'll do 3. The system below describes the lavender shaded region of the graph. Notice that there are two boundary lines. So when you are shading two different things on here, it's important to notice that this first side was shaded by the pink line, and then this second one was shaded by the blue line. Our solution is where these two things overlap. So that's what you need to look for. The overlap of this part is this guy right here. So on our tests and quizzes and anything I give you with this, I want you to label that you know where the solution is. So you could either circle it, or you could write a big S in it saying this is the solution, whatever makes you feel better, but I need to know that you know where the solution is. Remember, a solution makes each inequality true, so it's got to work in both of these, just like we did before. So solve the system by graphing and then check your solution. So let's pick the first one. It's already in y equals mx plus b form, so I'm going to start down at -3. I'm going to go down 3, 1, 2, 3, over 1, 1, 2, 3, over 1. I can go up 3 over 1, make as many of these as you need. And then because of this, I am going to draw a dashed line. I don't want to include the line. So dashed, I don't know what's going on down at the bottom of my screen. Dashed line. And then read what this says. I want all the y values that are greater than this line. So y values greater than this line are here. So that means I want everything on this side. So before, we would just be done and we'd move on. But now we got to graph one more line. So just like the last one, this is n y equals mx plus b. I'm going to start at 2. And then I'm going to go down 1 over 2, down 1 over 2, up 1, backwards 2, up 1, backwards 2. And before we would really care about this dot here that they both share, but we don't anymore because we want the whole part that is double shaded. So this is a less than symbol, so I'm going to shade all the things less than this dashed line here. So our double shaded region, if we shade all this stuff, is going to be right here. This is our solution. This is the double shaded part. So you can either shade it in a different color like I'm doing here. You could really scribble it in with your pen or pencil. You could write the word or solution or even put an S there. But I need to know that you know this is where it is, that it's this guy here. All of our solutions are in here. So like this said, we need to check our solution. So that means we need to find a point that is in this double shaded region. And it doesn't really matter which one you pick. I'm really excited though because 0, 0 is in this double shaded part. And that is really easy to plug in. So let's plug it into both equations. I want to know, is 0 greater than -3 times 0 minus 3? If we simplify, we get 0 is greater than -3, which we know is true. And now let's plug it in the second one. Is 0 less than -1/2 times 0 plus 2? So if we simplify, is 0 less than 2? It definitely is. So I know I picked the right solution area. Let's try another one. So the first equation that I see here is ny equals mx plus b. Let's graph that. 1, I'm going to go up 1, 2, 3 again, over 1. Let's go some back, 1, 2, 3. And then because it is a less than or equal to, I am going to draw a solid line through these points. And because it's less than, all the y values that are less than are down here. So where I'm going to shade is going to be everything this way. So the next one, it is in standard form. You can graph it in standard form. The one thing that messes you up with standard form is reading the inequality symbol. So if you know you're messing up with that already, I would suggest just changing it to y equals mx plus b, and it'll just make your life a little easier. And if I divide everything by 2, what I'm going to graph is y is greater than negative 2x minus 4. So down here at negative 4, and then I'm going to go down 1, 2 over 1, or you can go up 2, backwards 1. And remember, we used to care about this point where they cross, but since we're doing inequalities, we really don't anymore. This one's going to be a dashed line, because it's just a greater than symbol. And then remember, I want all the y values greater than this point, so they're going to be everything here. So that means when I go to shade, I'm going to shade everything up here. Now this solution area is way bigger than the last one. It is all of this stuff, this giant area right here. So when I want to check something, 0, 0 does happen to be a part of this solution again, which is awesome. But remember, you can pick absolutely any of these points in here. Any of these points should work in both equations, so it doesn't really matter what one you pick. I'm going to pick 0, 0 just because it's easy. Oops. So let's plug it into this first one. Is 0 less than or equal to 1? It definitely is. If I plug in 0 for both of these, I get 0 is greater than negative 8, which it definitely is, so I know I shaded the right part. So let's do a story problem. Suppose you want to fence in a rectangular garden plot. You want the length of the garden to be at least 50 feet, and the perimeter can be no more than 140 feet. Solve by graphing to show all of the possible dimensions of the garden. So without them saying this, you have a rectangle, and there are 2 dimensions to every rectangle. You have a length and you have a width. So remember, for perimeter, it is 2 of your lengths plus 2 of your widths. So let's tackle the first equation. We want the length to be at least 50 feet. So length, or L, you could make this X if you really wanted to, needs to be at least 50. So we would be okay with it being exactly 50. We would not be okay with it being anything less than that, so we need a greater than or equal to symbol here. And this is going to be one of the equations that we graph. Now usually on here we have x's and y's, so let's change this. Let's make this width and let's make this length. So if I want length to be at least 50, I'm going to find 50 and draw a solid line here because exactly 50 would work, but I want everything above here. I don't want anything below 50. Now, if I take a look at this other one, since I made this y, we can change this and it'll make our lives a little easier. This is y, and then this will be x. So 2y plus 2x, we can think of it here. So I want the perimeter to be no more than 140 feet. So my perimeter, I want to be 140 and no more than that. So for some people, changing it around like this will make it a little easier. No more than 140, again, means I'm okay with exactly 140, but it's got to be less than or equal to that. So if I want to graph this, I would suggest graphing this one in standard form just because, oh wait, all of these are supposed to be 20, 40, 60, 80, 100, sorry, add those zeros in there. because if not, our slope is going to be really small and we're not going to be able to see it on this graph. So instead, what I'm going to do is I'm going to graph this in intercept form. So if I plug in 0 for x, that means y would be 70. If I plug in 0 for y, x would be 70. So 70, 70, 70 on the x, 70 on the y are going to be my 2 points that I use. It's going to be another solid line because it can equal. And then think about what this is saying. I don't want x's and y's to be any bigger than 140. So where I'm going to shade is everything that is less than this line. And then we can see our solution area is a really, really, really small section. And if we erase some of the stuff around it, hold on, let me draw my lines back on. My eraser got a little crazy. Our area is this little guy right here. That's where all of our solutions can be. Now we can't have anything over here because that would imply negative width, and we can't have anything down here because that would imply negative length. So it's basically just this little sliver right here. So if you picked any point in there, it's going to work. So like this point right here, that's going to work. Even this point right here, and this point right here, and this point right here, all of these points that you can find in here will work. So that's why we have to shade it in so then we can see all of the solutions. Now if you're asked for a specific solution, you can give one, like 0.40 is this point right, or 0.50. But then stop and think about that. Does that make sense? Can you have either your length or your width, it doesn't matter which one, a value of 0? Doesn't make sense. So we want to take a look at one that's somewhere in between here. Like this would be a good one, 20/50. That means if I have a width of 20 and a length of 50, I would have at least 50 feet for my length, and my perimeter would be no more than 140 feet. So now that you've seen a couple of these, you have one to do on your own. Make sure when these are cents that you either put them as 0.20, 0.34, or what I would recommend doing is make this 20, make this 34, and then make this 240 cents. And it'll make your life a lot easier. If you need to relabel this graph, go ahead and do that. Make sure you write down any questions you have, and we can go over this in class. Enjoy your night.